Okay, and welcome to the growing cycle. This is the second video on the growing cycle on Vitis Vinifera. We'll be observing flowering and fruit set great development stage, the harvest stage. Vitis goes through several stages throughout the four seasons. Let's remember that seasons timings at the northern and the southern hemisphere. Also, stages overlap as the previous stage ends and continues into the next. Stages may have substages such as great development. At the end of this lesson, you will have a clear understanding of the following: how the vitis grows during the different stages of the cycle, the season during which the cycle passes through, and how the grower's responsibility plays a decisive part together with the ecosystem's weather condition. Stage 4, flowering and fruit set. So this happens between March and July in the northern hemisphere, happens September through January in the southern hemisphere. So at this stage, the plant needs warmer weather. We know at least 70 degrees Celsius, which is about 63 degrees Fahrenheit. So a little bit warmer temperature than the previous stages. It needs light, it needs warmth, as we said. It needs sufficient water and sufficient nutrients for the buds to bear juicy fruits for the next growing season. Now, what would be a bad situation? Well, it would include, for sure, rainy season, a lot of rain. If it's too cloudy, if it's too windy, if it's colder, then it has to be. So shoots for next year will grow from compound buds that stay dormant until spring. Why? Well, because temperatures were too low. Maybe there were too much shade on compound buds, not enough water, not enough nutrients. They can all limit bud fruitfulness. But also, let's not forget, it may influence also the flower clusters that will grow from a bud in the next growing season. Since each inflorescence will turn into a bunch of grapes, the weather at this point in the growing season can have a big effect on the output for the following year. Still, there are some differences between the different kind of grapes. For example, Riesling can grow buds that could be fruitful at the low temperatures, which makes it a very good choice for cooler regions. How does pollination happen? Let's look for a moment at this fascinating process, especially within the Vitis vinifera. Please do not mind my drawing. For copyright reason, I have to draw my own drawings, but the pollination itself is such a fascinating process. Let's look into it. It's very easy. In the grapevine, especially, we have hermaphrodite aspect of it and also the cross-pollination. Now, at the base of the leaf stalks, the petioles, on the new shoots, there are growings, new buds form. Now, the stamen, as you can see on the left side, is the male part of the flower. It is made up of two main parts: the anthers, pollen grains are made in the anthers; filament, the anther is held up by the filament; and the pistil. The pistil is the part of the flower that reproduces the egg. So what is in it? Well, we have the stigma. The stigma is where the pollen falls and sticks to the flower. The style is a thin shaft that goes from the stigma to the ovary. The ovary has ovules, which could become seeds. Pollination. Pollen moves from the male stamen to the female stigma, which is called pollination. Here, the pollen germinate and form, as long as the conditions are ideal, pollen grains will grow. So let's quickly review what the vine needs at this stage. It needs warm temperatures, at least 17 degrees Celsius, and sunlight, it needs warmth, it needs sufficient water and nutrients for bud to be fruitful and to produce enough crop for the next season. How about unwanted conditions? Well, it could be too rainy, could be too cloudy, maybe too windy, and also it could be too cold. Let's keep this in mind for the next following concepts. Just quickly stating here the difference between prime buds and compound buds. So prime buds will burst, making new shoots called lateral shoots. We talked about buds during the anatomy of the wine section. Prime buds are the buds that are going to produce green shoots in the current season. Compound buds will produce shoots next year, and they're usually dormant during the same season and burst during the following spring. Now, flowering and fruit set, if they are successful, will determine the performance level of fruitfulness. During this process, the pollen-filled stamens, which are made up of an anther and a thread or filament, are shown. The grape grower will watch out for the following: extreme low temperature. We talked about the below negative 25 degrees Celsius could kill the vine. It will watch out for too much water stress and also the lack of nutrients, nitrogen, water, phosphorus, potassium, and magnesium. They can all affect how many clusters of fruit buds during the next season will be produced. Also, what is the weather like? Because each influence will turn into a bunch of grapes. The weather at this point in the growing season can have a big effect on the output of the following year. Let's remember also that there are some differences between each different types of grape variety. So why do you think Riesling is so commonly called appellation in the old world? Very simple, as we said before, because Riesling likes to bud at low temperatures. So if that's the case, it's perfectly suited for countries like Austria, Germany, France, like Alsace, in Italy, like Sud Tyrol. So when is flowering successful? Usually flowering happens 8 weeks after the buds open. However, this time depends a lot on the temperature. When it's warm, the flowers open earlier. When it comes to blooming, a minimum temperature of 70 degrees Celsius or 60 degrees Fahrenheit is also helpful. At these temperatures, a single inflorescence can open from start to finish in just a few days. Low temperatures, though, can make blooming last a lot longer, with weeks going by between the beginning and the end. It follows that this makes it less likely for the grapes to ripen evenly. Now that we have seen what it takes to have a successful flowering, let's take a look at a successful fruit set. Not every flower turns into a grape. Around 30% of flowers turn into grapes, but this number can be anywhere from 0% to 60%. If we have temperature between 26 degrees and 32 degrees Celsius, or 79 degrees and 90 degrees Fahrenheit, these are the best for pollen to actually germinate. Conditions that are cold, wet, or windy can slow the growth of pollen tubes. This can lead to an uneven fruit set and is a major reason why crops don't produce well in cool areas. Conditions that are hot, dry, and windy can cause the vine to lose water, and that can also be negative. So a state of the grape bunch in which a lot of the flowers have failed to set fruit is called colure. This is what happens when the ovules don't fuse together properly and no grape grows. So a small amount of colure is normal, but too much of it can drastically lower the output. Too many or too few carbs can also lead to colure. This can happen when photosynthesis rates are low, which can happen when it's cold and it's cloudy, and when it's hot and dry, and there is a lot of water stress. It can also happen when fast shoot growth takes carbs away from the flower head. Heavy use of fertilizers, very rich soils, and strong rootstock can all cause shoots to grow quickly, which can cause colure. Also, some grape types are naturally more likely to colure than others. For example, Grenache, Cabernet Sauvignon, Merlot, Malbec, and Others are very likely to color. Corrosion is induced by an excess or lack of carbs. Low photosynthesis rates can be the cause of all this. This can happen when it's chilly and it's overcasted or hot and dry with a lot of water stress. The vine stops photosynthesis to conserve water. This can also occur when rapid shoot growth depletes carbs reserves in deflorescence. Rich soils, excessive fertilization, and strong rootstocks can all cause shoots to grow rapidly, resulting in color. Color can also affect certain grape varieties more easily than others. Grenache, Cabernet Sauvignon, Merlot, and Malbec are all extremely probable to occur. Okay, so midrandage is another example of an unsuccessful fruit set. This is a state of the grape bunch in which there are a lot of grapes without seeds. The grapes without seeds can still ripen, but they are smaller than the grapes with seeds. And because of this, midrandage may lower the amount of wine that can be produced. Some seedless grapes stay small, green, and young, which can hurt the quality of the wine. Midrandage can happen when it's cold, when it's wet, and when it's windy. Some grape types, like Chardonnay and Merlot, are more likely to get it than others. So let's quickly summarize these concepts of flowering and fertilization, which obviously are part of pollination. Now, we know that there's flowering happening when stamens, as we see here in the drawing, are made of an anther and a filament are shown. Now, fertilization happens when the pollen grains fall off and land on the wet stigma surface. Each pollen grain will eventually create, produce pollen tube. This pollen tube will go through the stigma and then to the ovule. Female reproductive cells contained in the ovary. Beautiful. Now, the pollen tube brings the sperm cells to the ovule where they fertilize the eggs. At the end, this makes a grape berry. The fertilized ovules grow into a grape berry, literally into a grape berry. There can be up to 4 seeds in a grape. Fruit set is the grape skins and the pulp are made when the wall of the ovary gets bigger. Once the flower has turned into a grape, we have a fruit set. Wonderful. This is nothing but the graphical representation of what we just talked about earlier. So it's the pollination, the flowering, fertilization, the fruit set. Very simple. You follow it left to right. We have the flowering, the pollen-filled stamens are shown with fertilization when the pollen grains fall off and land on the wet stigma surface. Each pollen grain makes a pollen tube. Then the pollen tube brings the sperm cells to the ovule where they fertilize the egg. There can be up to 4 seeds in a grape. Fruit set is when the grape skin and the pulp are made when the wall of the ovary gets bigger. And once the flowers turn into a grape, we have fruit set. Wonderful. We're finally arrived to stage 5, grape development. So verizon and berry ripening happens June through October in the northern hemisphere, December through April in the southern hemisphere. The vine at this stage needs the following. It needs enough sunlight, warmth, mild water stress. It cannot have an extreme water stress situation. What are the adverse conditions? Well, if we have too much water and too much nutrients, excessive shading of the grapes, which is too much vigor, very cold or very hot conditions throughout the day and night. Okay, so what happens immediately after fruit set? As the hard green grapes grow, more tartaric and malic acid accumulate. Aroma compounds and aroma precursors. Aroma precursors are compounds that do not have any scent but will convert into aroma compounds during fermentation, also form. Methoxypyrazines are classified as aroma precursors. Wines created from Sauvignon Blanc, Sauvignon, both Cabernet and Cabernet Franc, may have green scent and flavor due to methoxypyrazines. Tannins can build up and be harsh, but the sun can help firm them up. Remember about this. This is very important. Sugar levels are low, water enters the grape, and the xylem, a type of transport tissue that transfers water and nutrients from the roots to various sections of the vine, does the majority of the work at this time. Too much water, too much nitrogen promotes shoot growth over vine ripening, which is not the correct process at this point in time. During the ripening period, grapes may become smaller due to mild water stress, resulting in lower juice yield and higher skin to pulp ratio. Shoots are continuing to grow at this stage, but at a much lower rate than earlier in the growing season. At stage 2 of grape development, we have veraison. For a few days, grape growth slows down. This is often called the lag phase. The walls of the grape cells bring chlorophyll in skin cell breaks down, making the grapes more flexible and bendable. Black grapes also start to turn red because chemicals called anthocyanins start to synthesize, which means they are made from simpler chemicals. So we have arrived at the third stage of grape development, ripening. We have divided ripening into sub-processes, okay? At this stage, it's likely the most critical for grape quality. We know the shoot growth should have slowed down significantly, sugar and water accumulate rapidly, and acid levels decrease. Tannins, color, and aroma precursors, together with chemicals, thrive in steady weather conditions with adequate but not excessive heat. Sugar buildup begins high and gradually decreases during ripening. Photosynthesized sugar practically almost ends. Water stress from heat and dryness can decrease photosynthesis and sugar accumulation. As the grape ripens, the flow of water in the xylem slows and sugar is transferred to it by the phloem. Grape transportation transports sugary fluid from the phloem to the grape, resulting in sugar buildup. Warm, dry situations increase grape transpiration and sugar accumulation. Grape transpiration is inhibited at cold conditions. Grapes tend to acquire sugar faster in warm, dry conditions than in cool, damp ones. Warm conditions can produce rapid sugar accumulation, resulting in high levels before aromas, taste, and tannins have fully developed. The second stage of ripening, stage 3B as I call it, while the grape's tartaric acid concentration remains constant, sugar and water accumulation dilutes it during ripening. Malic acid decreases more than tartaric acid. The ripening stage permits respiration to metabolize malic acid, although sugar is metabolized first. Cooler climates increase wine acidity due to slower respiration. During the final month of ripening, temperatures above 21 degrees Celsius produce rapid acid loss and increased pH, while temperatures below 15 degrees Celsius reduce acid loss and avoid mast acidity. Nighttime colder temperatures limit malic acid loss during breathing. For example, Central Otago and Washington State wines have higher acidity than wines for milder evening temperatures due to considerable diurnal fluctuations. Methoxypyrazines level diminished through ripening. However, cold temperatures and insufficient sunshine due to bunch shading or cloud cover may provide grassy smells in wines. During ripening, fragrance molecules and precursors like terpenes rise, providing floral and citrus smells like Muscat's grape's aroma. Wine flavor traits come from the same components as scents, but they reach our sensory tissue differently. Aroma compounds are precursors of scent and flavor producing chemicals. Grape types, natural resources, and heat and light affect aroma compound and precursor synthesis in various ways. Grapes contain several aroma compounds and precursors, and heat and light can alter their formation, degradation, and preservation. While a clear correlation between ripening circumstances and grape scent components is difficult, tasting evidence suggests that grape varietals cultivated in certain climates have more of certain aromas. Chardonnay smells like stone and tropical fruit in warm climates, and green and citrus in temperate climates. The example illustrates that warmer, brighter climes create fruits and wines with more mature aromas. Okay, so here we are at the third part of ripening. We have initially proposed ourselves to divide the ripening into different processes, but the ripening is too big and too complex. And so we felt the need to divide it into several different stages so that it can be adequately understood. Now here we are at the third stage, and we see that black grape tannins peak at veraison and decrease during ripening. Tannins generate massive chains or networks from microscopic molecules. This reduces bitterness. Sunlight helps grapes build tannin and polymerize post-veraison. Let's remember, tannins are composed of two types of phenols, a broad and diverse group of plant compounds, flavonoids and non-flavonoids. Flavonoids are the ones truly responsible for the taste of tannins in the wine. Now, tannins are created from individual monomeric, mono implies single, flavonoids linked together to form polymers. Poly means many, a process known as polymerization. Okay, now let's move on to white grape. So white grape tannins are low. That's why makers rarely extract them by skin contact or other techniques. With sufficient sunlight and temperatures between 50 degrees Celsius and 25 degrees Celsius, anthocyanin rises significantly throughout ripening. Ripening time depends on many factors. Grape varietals, for example, some ripen earlier. Chardonnay and Pinot Noir ripen early. Cabernet Sauvignon Grenache ripen late. And Zinfandel grapes can overripe or underripe. Warm, dry weather speeds sugar ripening. Too much heat or dryness can shut down the vine, inhibiting grape growth and ripening. Vineyard and vine management control high yields, canopy shadow, and robust shoots, which can delay ripening. Harvest timing is affected by human factors as well and environmental factors. Let's keep in mind that all this is going to make more sense once we arrive at the end of stage three ripening. Okay, so we have finally arrived to the last stage of ripening, 3D extra ripening. So grapes shrivel when left on the vine. The flow no longer imports sugar or water into the grape, but water loss by transpiration continues and concentrates sugars. This stage can also produce extremely ripe scents. These may be beneficial in certain wine types, but not in others. Grape shriveling is frequent in hot, sunny, and dry climates. Additionally, certain grapes varieties, just like Syrah, are particularly sensitive. We must watch out for weather and disease threats. Sometimes they make it impossible to leave grapes on the vine all the time. So the last changes in the vineyards, let's remember, happened in the late summer, where the late summer transforms green shoots into woody, hardwood. They're referred to as canes. As leaves fall in autumn, vines store carbs in their roots, trunk, and branches, entering into a dormant phase. Grape farmers and winemakers try to harvest grapes that are ready for the desired wine style. The adjective ripe may change depending on several aspects. Grape sugar levels are a key sign of ripeness. Dry wines have a direct relationship between grape sugar and alcohol content. Grape sugar levels in sweet wines influence both the ultimate sweetness and the alcohol concentration. Grape acidity has a considerable impact on the taste and maturity of wines. The appropriate acidity level varies by wine type, with large quantities favored in sparkling and sweet wines. The aroma and flavor characteristics of grapes are critical in assessing harvest readiness. This parameter fluctuates depending on the grape grower or winemaker and the intended wine style. As grapes ripen, their aromas change from underripe and herbaceous to fresh, ripe, and even jammy or cooked. Another important red wine factor is tannin ripeness. Skin tannins build during grape development but are harsh in flavor. During ripening, tannins polymerize and reduce bitterness. The complicated link between tannin compounds in grapes and tannin feeding in wine is poorly understood. Tannin molecules derived from grapes react with other compounds during winemaking and maturation, potentially altering their expression. Tannins can be felt differently in wines such as softening with residual sugar or astringency in dry wines with strong acidity, even without these reactions. Generally, winemakers aim to avoid bitter and ripe tannins, which influences harvesting decisions. Different factors like sugar, acidity, fragrance compounds, and tannins are affected by the growing environment. Grapes accumulate sugar faster in warm, dry regions. Hot weather and water shortages may cause water stress, slowing ripening. Grapes may struggle to reach sugar maturity before cold and wet fall weather in colder climates. In order to complete this video, I've used some resources. The most important one is WSET Manual D1 for Level 4 WSET certification on viticulture. Also, I've used some other resources online in regards to biology, uh, photosynthesis, pollination. And I also wanted to mention that the images or video that have been used in this material that have been produced by fireflyadobe.com, which are artificially intelligent created. So they are proprietary material. And they have been sourced also at pexel.com, which are completely copyrighted free. Thank you very much. To the next one.